Okay, well, we are moving forward with our parallelograms, and as we move down the polygon family tree, our next section talks about rhombus and square. We do these together, so let's take a look at it. Um, Recalling our polygon family tree, we had five properties of a parallelogram. We took those with us and we added two that make us a rectangle. Well, we're going to do the same idea. We're going to take those five with us and we're going to add three for a rhombus. But then we're going to talk about a square, and a square has nothing new. A square inherits. Um, a square inherits all 10. So a square is a rectangle. It's a special kind of rectangle. It's also a special kind of rhombus. It has all the properties of a rectangle and a rhombus, which of course includes parallelogram. So we're going to see after we learn the three properties of a rhombus, we have effectively learned all the properties of a square as well. So let's get right into it. The properties of a rhombus include the five properties of a parallelogram. So remember things like both pair of opposite sides are parallel and both pairs of opposite sides are congruent. We also have both pair of opposite angles are congruent. Consecutive interior angles are supplementary. And the diagonals bisect each other. Now, for a rhombus, we're going to take that parallelogram, turn it into a rhombus when all four sides are congruent. The diagonals are perpendicular to each other, and the diagonals bisect those opposite angles. So the opposite angles are congruent in any parallelogram. In a rhombus, they're also bisected. The diagonals bisect each other in all parallelograms, but in a rhombus, the diagonals are also perpendicular, forming a right angle. And all four sides are congruent in a rhombus. So let's take a look at our picture here with all of the properties labeled in. And we're asked, what can we determine about these four triangles that make up a rhombus? We have seen this kind of question before. Well, we have four scalene triangles. In fact, more specifically, we have four right scalene triangles. In a parallelogram, they were scalene. In a rhombus, they are right scalene. And if we look carefully, all four triangles are congruent. Instead of just the opposite pairs, that's still true, but now they're all congruent. So again, what was true for a parallelogram is still true, but as the shape gets more specialized, the triangles that make it up get more specialized as well. All right. So let's look at a rhombus example. Here we have a rhombus drawn in WXYZ that the diagonals intersect at V. So we should probably add point V into the picture. We are given angle XZY is 34. Now, we notice that those letters are missing, so we have to fill some things in here. It's called XZY. So XZ is at the vertex, and then the only other place to put Y is at the bottom right. So we have to fill in information based on our knowledge of how angles get named. WV is 7, and and we're asked to find some different measurements. So let's go for it here. Let's see what we can do. Number 13, angle WZV. So I want to find it first. WZV right here. Well, the diagonals are bisected. Or, I'm sorry, the diagonals bisect the opposite corners. So that tells us that angle is 34 degrees. Property of a rhombus is they bisect the opposite corners or the opposite angles. Let's take a look at another angle XYZ. So again, I want to find it, angle XYZ, this big angle right here. Well, we're going to call it, let's call it Y, a variable there. We can do this a few ways. One easy way is that the consecutive interior angles are supplementary. So we've got the one angle made up of 34 plus 34, and then the angle that we're looking for, angle XYZ, and that has to equal 180. So we can find out that our missing angle excuse me, our missing angle obviously here is 112. Excuse me. The other thing we can do is we can work inside one triangle, get that little corner angle, and double it. So we've got a couple different approaches here. And, again, we can work within that little triangle because we know that in a rhombus, the diagonals are perpendicular. So if we wanted to work inside the one triangle, we can say the 90, the 34, and that corner of the triangle would have to add to 180, so we would get 56, and then we would double it for the other 56. So again, different approaches. WY, well, WY is the entire diagonal. We know that diagonals are bisected, so both sides are 7, making the entire diagonal 14. And finally, we are asked to find XY. XY is this side on the outside, right out here. Now, we don't know any of the other sides. All four sides would be congruent. We don't know the other sides. But what we do know here, and I'm going to redraw a part of the picture, we're looking for this side. But what do we know here? We know it's a right angle. We know it's a right triangle. We know one side is 7. And we know our angle. So as problem solvers, we want to identify what do we know and what can we do with that information. Well, we're going to have to recall back here and do some trigonometry. The cosine of 56 degrees equals the adjacent over the hypotenuse. So I'm just going to give it a variable like z. And now we can do some trigonometry and find out that our hypotenuse there measures, well, I need my calculator to wake up here. 12.5. So now that we have right triangles, because the diagonals are perpendicular, we want to recall things like Pythagorean theorem and trigonometry. Since we learned all of our properties of parallelograms, rectangles, and rhombus, we're going to bring them all together to form our square. So we can see our one screen here showing all the properties of a square. If we fill in a few blanks, we have the 5 properties of a parallelogram. We learned 2 about rectangles. We learned that the diagonals are congruent and that we have 4 right angles. All the corners are right angles. The sides are perpendicular. For a rhombus, we said the diagonals are perpendicular. The diagonals bisect the opposite angles, and we have 4 sides that are congruent. All 10 of those properties together form our square. So just like we did with all the others, we can look at the shape where everything is filled in for us, and we can see how the square inherits all the properties of the other parallelograms, but the triangles also inherit various properties. So if we look at our 4 triangles that are formed here, now we have 4 congruent right isosceles triangles. So all 4 are congruent, all 4 are right isosceles. With one diagonal, we have a right isosceles. With both diagonals, we have 4 right isosceles. And let's go solve a problem or two. So here we have the diagonals of square EFGH intersect at J. That's all drawn. GJ is 15. That is shown to us, and we're asked to find a few measurements. So let's start with number 21. Angle EJF. EJF. Well, we inherited the properties from a rhombus that the diagonals are perpendicular. So 90 degrees. Angle JFG. JFG, this little angle right here. Again, we know that like from a rectangle, we inherit the property that all the corners are 90 degrees. And from a rhombus, we inherit the property that the diagonals bisect the opposite angles. So it's 90 degrees in the corner, but each of those little angles are equal. They are bisected. So 90 divided by 2, and we get 45 degrees, which supports that it's a right isosceles. Segment FH. FH is the entire diagonal. Well, again, the diagonals are bisected. That's true for all parallelograms. So the diagonals are bisected, making each side of that diagonal 15. But we inherit from a rectangle that the diagonals are congruent. So each diagonal in this question is 30. So diagonals are congruent and diagonals are bisected. And our last one here, EJ. Find it, EJ. We already labeled it. We actually did that to help us with the previous question. It is 15. Diagonals are bisected and the diagonals are congruent. So with a square, there's absolutely nothing new. We inherit all of the properties, all 10 of them, from the other parallelograms. All 4 are parallelograms. A square is a rhombus. A square is a rectangle. They are all parallelograms. Sometimes a parallelogram is a rectangle if it has the extra 2 properties. A rectangle is not a rhombus. They are different. They have the same parent, a parallelogram, but then they have properties that make them very different. But a square inherits all the properties. Okay. Let's see. We've got 2 more questions here. So let's see. In our first one, we are given a rhombus and we're asked to solve for x and y. Well, solving for x, we're shown that those segments are congruent. But we also know that in a rhombus has 4 congruent sides. So 5x plus 6 equals 8x, and x equals 2. Solving for y, we're working with the angles. Consecutive interior angles are supplementary. So we have 97 plus 12y minus 1 equals 180. So combining like terms, 96 plus 12y equals 180. And of course, we can solve it from there. 12y equals 84 and y equals 7. Looking at our final question here, we're working with a square. And again, we're solving for x and y. So let's start with x. Look at the parts that have an x. They are the opposite sides. The picture's already marked, but we also know in all parallelograms, the opposite sides are congruent. So 2x plus 1 equals 4x minus 7. That's 2x, 8, and x equals 4. In a square, all 4 sides are congruent. So now we can plug it in and we can get KL and NM. They're all 9. For solving for y, let's find our angle. Y is our angle right here. We know that every corner is 90 degrees. And we know that in a square, because it inherits the property from a rhombus, the diagonal bisects that angle, the opposite angles. So 7y plus 3 is really equal to a 45-degree angle. So that makes 7y equals 42 and y equals 6. Okay, so we have our rhombus and square to wrap up our parallelograms.